As promised, here's the detailed long-form guide to creating a cable slide. Based on the lack of engagement with the shorts version, I wanted to make this clearer, a bit more beginner-friendly, and easier to follow. I fully admit that the shorts version was rushed, confusing, and too fast-paced. Lessons learned. Let's dive into the improved version. Before we start, here's what you will need. Dreamteck Splines. It's free on the asset store. This makes this whole process a lot easier. A character movement system that can be overridden during the slide. For example, Unity's character controller, which in my case I temporarily disable while sliding. First, create an empty game object and name it cable. Add a tube generator to it. Then, add a spline computer as a child. Modify the spline shape to match your intended path, and add the spline as a reference to the tube generator. Pay attention to the spline's normals. This determines the player's orientation while sliding, so modify it accordingly. Add another child to the spline object. This will hold both the script and the trigger collider. So, create the collider, adjust its size, and make sure it covers the entry point for the slide. For interaction, ensure the player object has a rigid body component, otherwise we cannot interact with the trigger collider. And a unique tag. We'll use this to identify the player in the script, just in case, to make sure that no other object could be causing the trigger, resulting in errors. Create the script and add it to the child we created earlier. Let's add these variables to the script. Cooldown, in case you want to have a cooldown for the sliding. Then a reference to the spline, a boolean to keep track if we are sliding or not, and lastly a list of vector trees to hold the cached spline points. Oh, I almost forgot, we also need an integer closest index. We save the index of the closest point here. In the start, cast the spline data into manageable segments, split into 100 points or something similar. Why? This ensures smoother player positioning by allowing precise control where the slide starts, based on the player's proximity to the spline. Without this, the slide may appear inconsistent and will always start from the very beginning of the spline, regardless whether you enter the trigger. Create the onTriggerEnter method. This is Unity's built-in callback trigger when a rigid body enters a collider marked as a trigger. In the method, check if the object that triggered that callback has the same tag as the tag we assigned to the player. If it does, we start a coroutine to handle the slide. Now let's get to the meat of this video and create the coroutine. First, find the closest point on the spline from the cache data to determine the starting position. Create a temp list of floats. This will hold our distances. Then, a for loop that goes through all our pre-calculated spline positions, and for each one of them, we calculate the distance to the player. Lastly, get the smallest value from the distances to get the index of the value. Create a local float named timer. We are going to use it to evaluate the spline. We can multiply the index by 1 divided by the amount of spline sections minus 1. In my case, it's going to be 1 divided by 100. Let's say we start at the middle of the spline. That is index 50. Then multiplied by 0.01. The result is 0.5, which is correct as the spline evaluated range is from 0 to 1. Also, remember to disable the character movement now. What is a coroutine anyway? Coroutines in Unity are a way to run code over time instead of completing everything in a single frame. They allow you to pause the execution of function and resume it later, which is useful for tasks like waiting for a few seconds, splitting expensive operations into multiple frames, or creating complex tasks easily and without blocking the rest of your game. If you're interested, check the description. There is a YouTube shorts video I made about creating a lift sequence using coroutines. Now we need a while loop that takes the timer as the condition. Inside the loop, each step we evaluate the spline and save it to a spline sample. Apply this result to the player rotation by taking the spline normal that we were talking about earlier. This way, the player up direction is the same as the spline's normal direction, and Unity has a convenient method to do this: set loop rotation. Also, don't forget to increment the timer. Lastly, we need to update the player position. I use a lerp here so we don't instantly snap to the starting position. So, what are we doing here? We lerp from the position the player was in when we started the slide, and go to the sampled position plus an offset. This offset depends on how your player has been set up, how tall it is, etc. so you have to modify the offset to your needs. When the slide is completed, remember to enable your character's movement again. We need to do an exit sequence, and we have to create another coroutine for it, called exit sequence. Although this is only required if you want to use a cooldown. In there, you just return new wait for seconds and use the cooldown timer as a parameter. After that, you set the sliding to false, and we are ready to go again after this time has passed. There are infinite improvements to be done, but here are a few examples to improve the future. 1. Adjust the number of cast points based on the spline's total length for proportional spacing, or adjust it to be smaller to save some memory and a bit faster execution. 2. Make the slide's duration depend on the player's initial velocity for better flow. And 3. Create a way to exit early. Maybe pressing space exits you from the slide, so you could check for a space key in the while loop and then just yield break out from it. Thanks for watching, and I hope this guide helped you implement smooth and immersive cable slides into your game. See you next time.